Hello, everyone. My name is Diana. I'm educational facilitator of RTsim company. I hope you hear and see me well. If you have any problem or issues, please let me know in our chat. And we have a few minutes, and you can invite your colleagues or your friends, share the link with them, and we are starting in a few minutes. Yeah. In these few minutes, feel free to send some reactions, maybe hearts or likes, to show your um, activity and your confidence. You know that the main uh, our mission of our team, mission of our company, is uh, is a bridge gap between theory and practice in energy industry, and give you opportunity, gain a confidence in your future career, and boost your career in each part of our world. Yeah. So thank you for your actions. I'm really happy to see so many participants here, so many young engineers and students who want to have an opportunity to gain confidence. Yeah, and you no need today your cameras or on voice. Maybe you can ask some. If you have any question, I will give you opportunity in the last part of our webinar. Yeah. So I'm very happy. I'm a honor to announce you opportunity to take part in one of the main championship in this year, 2025 RTsim downstream operator training simulators competition. It will be it will held championship held on 3rd December. You can participate fully online on your personal computer. Full details will be provided you after registration. So just scan the QR code on the right bottom corner, or click on the link in Google Chat. I will. Okay, I'm resend the links and pin it. And after filling registration, you will, if you already have RTsim career software access, you no need to gain a new one and use your login. You can use your login and password. But if you don't have, we'll give you a free trial license for a few months. So today, the main topic of our RTsim stream is amine treatment unit and common mistakes and how to avoid them. You know, I think some of you already have take part in our webinars or or other intensive, maybe on a previous championship, but on a preparatory webinars on or other webinars, we don't have time to give a very important theory. So the stream will help you better understand the theory, the inner processes in amine treatment unit simulator. Yeah, and let's start. Yeah, the main classification of chemical processes is but by driving forces, mass transfer processes like distillation, absorption, extraction, hydromechanic. The second type is hydromechanical process, mechanical processes, heat transfer processes, and chemical processes. So in our amine treatment unit simulators, only mechanical processes don't presented. Other processes are presented, and I will show you. And about impurities in hydrocarbon gas, I think you know. Yes. So first of all, let's look at our amine treatment unit simulator, and to make our workspace more convenient, I suggest you use TF mouse and to have an opportunity manipulate and adjust new parameters. On click, we should start the calculation of our model. And in these simulators, there are absorption column, 2 pumps, and heat exchanger. And natural gas enters the column for purification, and its feed to the bottom of the column, rises to the top of the column, and it's purified thanks to monoethylenamine entering to the top of the model. And using show photos feature, we can see how this absorption column looks like on a real plant. Pumps and heat exchanger. Yeah, is photos of real units on a petrochemical plant, and gases that are formed in different production processes during oil refining entering for purification in our column, and commonly gases collected from several units, or maybe it was natural gas, and because it is increased economical efficient and from several units, and after direct to column to our absorption column for purification, and because it's increased economically efficient and environmental compatibility, therefore everything can be recycled, sure direct to recycling and by the production. And after purification, gases that come out from the top of the column are used as a fuel gas on furnaces or other units. And these amine treatment units are presented on the main different type of plants, including in particular oil refining, primary refining, or on a polymer production, maybe on a ethylene production, and but for the main reason of amine treatment, yeah, I see your question. Will they record? Yeah. I'm recording this training, and I will share the link on when I upload to YouTube. Yeah, and hydrogen sulfate is dangerous for furnaces due to sulfur corrosion and burners destroying. And amine treatment unit clean fuel gases for of hydrogen sulfate. And let's back to our presentation, and the dangerous impurities of the hydrocarbon gas. And hydrocarbon gases, in addition of the hydrocarbon themselves, may contain various harmful impurities that negatively affect processing and equipment operation. First type is acidic impurities. These components react with water and form corrosive compounds, carbon dioxide and hydrogen sulfate. The second type is a water. Water vapor is a liquid. Moisture can lead to hydrate formation, corrosion, and operational issues in pipelines and equipment. You can see the natural gas and you know, yeah, the registration process still ongoing. You can fill the form, and now you can see the leak with a lot of hydrogen sulfate and mercaptans. And the third types of impurities is mechanical impurities, and solid particles such as dust, rust, or catalytic fines that contaminate the gas stream and cause corrosion or plugging of process lines. Mass fraction of hydrogen sulfate and mercaptans of char, not more than, including hydrogen sulfate, and it's in normal not more than 0.003%. And about desulfurization, or other name for this is sweeting. Ethyl mercaptan, ethanol, and hydrogen sulfate are toxic substances that pose serious health hazard to operating personnel, and they have extremely unpleasant odor. Hydrogen sulfate smells like rotten eggs, and mercaptan have a strong nauseating odor, even at very low concentrations. So mercaptans and hydrogen sulfate are poisons and have extremely offense odor. And second main reason is a corrosive environment formation. In the presence of moisture, water vapor, both hydrogen sulfate and mercaptans form acids, corrosive media such as hydrosulfuric acid, and these compounds cause corrosion of pipelines, heat exchanger, and equipment, leading to leak and failures. You can see the corrosion on pipelines on the second photo. And in humid conditions, sulfur compounds form corrosive environments that damage process equipment. And catalytic poisoning, mercaptans and other sulfur compounds are poisons for refinery catalysts used in reforming, cracking, and hydrogenation. Yeah, I'm sorry. And even trace amount can deactivate catalyst and decrease the efficiency of this catalyst, and reducing process product yield. And mercaptans are catalyst poisons that deactivate refining catalyst. And sure product quality and environmental regulation. Sulfur compounds deteriorate the quality of fuel gases, and increase emission of CO2, and they are restricted by environmental standards all over the world. And desulfurization injures compliance with clean fuel specification and air quality regulation, and removal of sulfur compounds improve product quality and reduce environmental pollution. Absorption method. Gas purification by absorption can be based on a chemical or physical absorption. And yeah, about classification of chemical process, we can see there are types of gas hydrocarbon purification methods, and our type is chemical and physical absorption, not adsorption. Yeah, and we will stop on these two parameters. And about the theory of this chemical absorption purification from hydrogen sulfate, and chemical absorption process really on a chemical reaction between hydrogen sulfate and active components of the absorption. Typical solvent, amines or alkene solution, for example, amide guaride, adip, and econamine. So econamine is diethylamine and water, and there are chemical absorption processes are highly selective for added components like sulfur and CO2 and allow deep gas purification. Physical absorption processes are based on the physical dissolution of impurities in special solvents. Common example includes ristresol is a cold method, purisol with N-methyl pyrisolate, and other method. But in our case, in the Amine treatment unit, the main is chemical absorption process. So you can see the scheme of our purification. Hydrocarbon gases and sulfur compounds enter to our column from the overhead part outlets purified gas, from the bottom hydrogen sulfate, and after it's sent to utilization or sulfur recovery. And we should always use monoethylamine for cleaning, and we can you have two flows of monoethylamine used or used from top or regenerated after the regenerator. Yeah, so this is a base scheme of our chemical cleaning, and the second type for equipment we can see on our scheme is the pumps. So let me give you some theory about pumps. And pump is a hydraulic machine used for pumping out, supplying, and ensuring circulation of various liquid media with a closed system. So hydraulic pumps are designed to cover mechanical energy into hydraulic energy and make flow rate and pressure of our flow rate, and also to train mechanical energy through a liquid as a drive for other mechanisms. There are really a lot of type of pumps, different types. piston pipes, single acting pumps, double acting. Here's double acting pump, and maybe one of the common use is diaphragm pump and external gear pump and screw or helical pump. But we use, and a lot of oil refineries use only use only centrifugal dynamic pumps, and in dynamic pumps energy is transferred to fluid by forces acting on it within a working chambers that are continuously connected to the inlet and outlet of the pump. So we have suction of pump and discharge of the pump with a high pressure. And in such pump, there are energy of a liquid entering the Epler, increasing, creating a vacuum in the suction pipe, and after passing through the impeller, the liquid enters to discharge channel or volute, where its kinetic energy is covered into static head pressure. So centrifugal pumps have advantages with a simple design, just few moving parts, long service life, and high efficiency, high performance, maybe steady, pollution-free flow, but there are two disadvantages. We cannot self-prime. High risk of cavitation. Cavitation is a process where when a lot of air bubbles in our liquid, and cavitation can destroy our pumps and other dynamic equipment. And the next disadvantage is performance strongly depends on head pressure and cannot handle multi-phase fluids and cannot pump highly viscous liquid. But these pumps, centrifugal pumps, using not only in energy industry, industrial sites, agriculture, wastewater systems, use pumps for centrifugal and other pumps for gas processing, drainage, water waste removal, fluid production, irrigation, or agricultural field. Food, chemical, and pharmaceutical industry. There are pumps used for production beverages and food products, and for pumping pulp, hydrocarbon, and paint or workers. So the most common application areas for centrifugal pumps include the aerospace, food, chemical processing, and pharmaceutical industry. Yeah, and about absorption column, our main units. You can see the scheme of our absorption column, and the main part is feed trays, bottom part, overhead part. The pumps you can see on this picture, and trays consist these trays between these plates, and there are a few special plates with a tray, and this tray, these plates with a bubble cup tray help us make separation, absorption processes. We can say one flow and two flow trays. So yeah, and I have finished with my theory. If you have any questions, feel free to use chat and ask. We have time to answer. And what should I upload in the Google forum last page? Okay, but okay, I understand that now the forum is not ideal. Our team will change it. So just join to our WhatsApp community, and I will share you notification when our team solve this app the question. In this page you should upload the screenshot that you have subscribed to our LinkedIn, to our YouTube, and to our Facebook. Yeah, and let's look on our simulation. And I have already opened it in technological process. No, I have launched it in individual training mode in the normal startup. So yeah, we guys forgot. No, the simulators, RTsim simulators focused on downstream processes. But I think for engineers, for students, is very important to understand the both downstream and upstream process. We forgot about heat exchanger. In this case, is T1. But about heat exchanger, we have a big stream. So I will share the link in the description, of this recording later, and you can now gain a theory about heat exchanger from our previous stream. And let's try start up and start up our unit, and I will draw your attention or main mistakes that users often do. Let's use a virtual instructor, and now the steps that should be done one by one already dropped in the bottom, and here is all action we need to do. So let's try to start up our column. I would like to draw your attention that using virtual instructor is a good opportunity to studying the processes, to studying technological requirements, but done of instructor actions don't guarantee you full 100 score, because they need all steps need to be done slowly, and you need to monitor the instrument readings. In the best to you is use reference information, but the instructor was covering was very convenient application through the workspace. And now in the process, we will pay attention to this. Reference information you can open in help and find here Amine Treatment Unit. and see all information. And let's try to start our Coleman. During the normal startup of the Amine treatment plant, Amine treatment unit, we first prepare the lines. To do this, we open the manual valves. There are steps from 1 to 9 from our instructor. So let's click on the first step and the sweet gas manual valve highlighted on the screen, and we need to open it. We are starting working with valves, flare gas system gas, about two manual valves. Yeah, other valves. You should understand that manual valves opened, but shadow valves haven't opened yet because manual valves controlled by hands by operator on the field. And next step is opening manual valves from bottom to pumps and in heat exchanger system. About heat exchanger, just to remind you that it's very necessary to understand the cooling and heating medium of our heat exchanging system. And first of all, if we start heat exchanging, start from cooling medium. If we launch, no, not launch, shut down our heat exchanging system, we should use, we should first of all stop heating medium. And others, then the next step. And we see, let's see which manual valves haven't opened. The one raw material gas purification manual valve, it's remained closed because it's too early to feed gas for cleaning, while monoethylenamine has not yet been fed into the column. The gas will simply exit the pipe and purified, and will continue along the process line and purified. And that is, will start the regenerated monoethylenamine first. And I also didn't open valve on the drain because we use the drain during shutdown. And we didn't open the manual valves Z7 because this is pipe to the atmosphere. We also need it mainly during cleaning and shutdown off because there is no feedstock in the column. And the manual valves on regenerated monoethylenamine in the heat exchanger is closed because it is this is hot circuit. And we always start the cold circuit always goes to the heat exchanger first. And when the hot circuit to the heat exchanger, I explained it here on a previous webinars or previous streams. And we do this in order to not damage the equipment. And next comes to the opening of shadow valves. There are points 10 and 11. And is the main one of the first main mistake is open all valves, all manual valves. First of all, you should understand which manual valve on this step is should stop, because if now we will open the gas for purification manual valve and lead to our raw material, our column will be fed first of all from first of all, by gas, and it will be very very hard to add in this common monoethylamine. But we should first of all fill our column by monoethylamine, and it's better to open or close our valves in by mouse wheel for a percentage, not for bottoms, not by red and green bottoms. So let's continue. The next mistake it's try to turn on to manipulate the device, the shadow valves or controlling device by on-field workstation. We should enter to DCS control room and manipulate from this window. So open our shadow valve and open the next shadow valve. In this case, we can open, just click open. And we have opened the shadow valves, and when we move on point 12, and this is device flow rate device of reclaimed regenerated monoethylamine, and now we are starting to fill our column, absorption column, with the regenerated monoethylamine little by little. There is already raw material in the section of pipe, and now we will gradually open regulation in order to check the regulator opening operation. The PV1 control valve is controlled by FIRC1 device. So let's click on control valve, and the next mistake is clicking on control valve. Control valve don't have own control panel because it's controlled from controlling from device temperature or level or flow rate device. And next step is open our manual valve for a few percent. Maximum parameter, maximum value is 15%. So let's click 50. And the next mistake is try to adjust new set point in manual mode or manipulate the PV. PV is a parameter in a conjugation, a current parameter. CV is a set point in automatic mode. NIVI is opening degree of our valve. And we see that the flow appears in device, and regenerated monoethylamine began to gradually flow into the column. Yeah. To be honest, I can understand. Okay. And our next step is turn our flow rate device to automatic mode. Let's click on man. Turn it to automatic mode, and let's adjust the set point. But next mistake is enter the parameters, the set point, adjust new set point above the maximum allowed value. Yeah, And next, we open the shutter valve at the pump outlet to open path from pumps to heat exchanger. Next, let's open the tier 3 device. Yeah, now in this, yeah, here we can see, yeah, I have set here 20%, and on this stream, we will focus on mistakes. So if you want to good quality theory and guide how to use simulator, join to our WhatsApp community, and I will share the links for base on Amine Treatment Unit. So now we have just opened shadow valve, and one of the main mistake is turn on the pump when our Coleman is not filled yet above from a minimum values. We can see that the minimum allowed value in our Coleman lower lock level is about 11%, and lower alarm value is 25%. So if we try to run our pumps, it will be working only just 1 second. And after emergency shutdown system, stop our pump. So understand the values of our of technological parameters, and these each mistakes can reduce your points on the championship. So it's all common mistakes, and I have shared with you how to avoid them. We will not finish a startup of our Coleman. Let me remind you that you can you can watch other webinars or on our YouTube channel to have an opportunity to join our channel. Just join to our WhatsApp community. Let me share you link for our YouTube channel. So yeah, thank you very much for your attention. You have minutes to ask your question. Oh yeah, I see one question. And is entering below the maximum point range is a mistake to avoid as well? Yeah. Good question, and I have answered this question just now. You should wait enough liquid level, healing level. No, not liquid level. Yeah, I have shared the link for our channel, and And yeah, so just join to our WhatsApp community, and I will share all necessary links and provide you information. Thank you very much for your attention. If you want to get a recording of this RTsim stream, subscribe to our YouTube channel and join to our WhatsApp community. Thank you very much for your attention. And last time, I invite you to our championship. And okay, let me say you on this competition. There are cash prizes for first 3 places. Then that don't waste this opportunity. Fill the registration form to our competition. Thank you very much for your time, and it's my pleasure to share with you this interesting information. And see you in our WhatsApp community and on the championship. Bye bye.